So in this video, we're going to talk about the domain of composite functions. We've talked about the domain of lots of other functions. We're also going to talk about domain in the context of composite functions. So if I have these two functions, f of x and g of x, and I am going to find f of g of x, which could be written either of these two ways, f of g of x or f of g, I guess you say it the same way either way, but written differently. What is the domain of that function going to be? Well, if we start by writing it out, it is the x function, but instead of writing x right there, we're going to write the g function, which is 4 over x minus 1. Now, in talking about the domain, there's two key pieces. One, there's the piece that you plug in. So if you see here, we have a fraction inside of a fraction. And that should look horrendous because it's horrendous, and we typically don't leave fractions inside of fractions. And in this moment, we're just talking about domain. But since we have this smaller piece inside of the larger one, but it's still a fraction, we can have an undefined value for that fraction, just that g function that's substituted in there. Because that alone could give us an undefined value, we first have to look at the domain of the g function. Anything that makes the g function, the 4 over x minus 1, undefined is not going to work for the g function or for the composite function as a whole. So our first check in talking about domain is to look at simply the g function. And the denominator can't be 0. If the denominator is 0, if we end up with 4 over 0, that would be undefined. So the question is, what makes x minus 1 equal to 0? Now hopefully that's not too scary, plus 1 plus 1. If x equals 1, we get an undefined value for the g function, that piece we're plugging in. So the domain of that function is everything besides 1. X cannot equal 1. All other values of x are okay. It could be positive, negative, big, small, whatever. It just can't be positive 1. Now, we also can look at it in the context of the entire composite function. I have 1 over something plus 2. Well, this can't be undefined either. And hopefully it makes sense to you that if this value right here is negative 2, if it were to be negative 2 right there, that would be 1 over 0, which would be undefined, which would be bad. So really, I just have to make sure that this g function, this part that I plugged in right here, I have to make sure that it doesn't give me negative 2, because negative 2 would make this blow up also. So then the question is, what would make 4 over x minus 1 equal to negative 2? That's the relevant question. Because whatever makes that g function negative 2 is also going to blow up this composite function. So we already know that it can't be x equals 1. X cannot equal 1, but we also need to know about this second piece right here. Anything that would make it negative 2 would blow this up. So I need to solve this. 4 over x minus 1 equals negative 2. So I'm going to start by multiplying everything on both sides by x minus 1. Doing so will clean out that denominator very nicely. That simplifies out, and I have 4 equals negative 2 times x minus 1. If I distribute that out, I get negative 2x plus 2. Negative times a negative is a positive, so I have 4 equals negative 2x plus 2. Subtract 2 from both sides, and I have 2 is equal to negative 2x. Finish it by dividing both sides by negative 2, and I have x equals negative 1. So that means if I were to plug in negative 1, into this g function right here, it would give me, inside that parentheses, it would give me negative 2. And negative 2 here plus the positive 2 here would actually end up giving me the 1 over 0, which we don't want. So what can my x values be? Well, it can't be 1 because that makes the g function that we plug in undefined, but it also can't be negative 1 because negative 1 would make the g function have a value of negative 2, which would give us 1 over negative 2 plus 2, which would give us this right here. So you have to check two things. You have to check what you're plugging in, what is the domain, what restrictions do we have for the part we're plugging in, and then also, after we plug it in, what can it not be? So there's two things we have to check. What we initially plug in and what we plug in gives us, does that create bigger problem in the larger composite function? Now, to make this a little more interesting, let's also do g of f of x. As in, we're going to flip the order on these. So now we're going to say the g function, 4 over x minus 1, except you know what? It's not going to be x. We're going to plug in the x function, which is 1 over x plus 2. What is the domain of g of f of x? So I said before, we have to check two things. We have to check what we plug in, which for the first one was right there. So in this one, it's actually that right there. I need to make sure that that part we're plugging in, the f function, is not going to give us an undefined value. So I need to know that x plus 2 is not going to give me 0. If I subtract both sides by 2, I get x equals, or does not equal negative 2. X cannot equal negative 2 because that'll make the part we're plugging in undefined. I also then have to do what we did on this part, which is check and make sure that after we plug it in, that it's not going to give me an undefined value. The only way this is going to give us an undefined value is if this parenthesis is positive 1. I got to make sure that I'm not going to get positive 1 out of that parentheses. Well, what we're plugging into that parentheses is 1 over x plus 2, and I need to make darn certain that I don't get 1, because that's going to blow this up. So I multiply both sides by x plus 2. And on the left-hand side, that makes the denominator simplify out real nice and neat. On the right-hand side, if I distribute that out, I get x plus 2. And if I subtract both sides, if I subtract 2 from both sides, I end up with x equals negative 1. So in this case, for g of f of x, the two pieces that I get that I cannot use in my domain, I cannot use the x value of negative 2 because that will give me an undefined value, but I also can't use negative 1 because that will also give me an undefined value. So you can check these however you want, but what you have to remember is first, you need to check what you're plugging in, the function that's being plugged in. Does it have any restrictions? Because you must honor those restrictions. And then second, you have to look at what you got after you plug it in and make sure that the piece that was plugged in the holistic composite function also checks out, which is why I made sure that 1 over x plus 2 could not be equal to 1 because we have that minus 1 right there. That's what I was checking. So two things you got to check. Make sure you check them both to verify the domain of a composite function.